Alright, today in this video we're going to be talking about expanding polynomials. Now let's start off by first defining the word polynomial. Now in mathematics, a polynomial is an expression containing variables, coefficients, and exponents. There can be addition, subtraction, multiplication, and division. However, there is one exception. There can be no division by a variable. So that is a polynomial, and today we'll just be working on expanding. Now, there are many forms of polynomials, so let's first take a look at this form. ax plus b, well, in parentheses, times, in parentheses, 3x plus cx plus d, rather. So in this case, we can see that there's one constant, or rather two constants, and only one variable, which is x. So let's try it with this example here. Expand 3x plus 7 in parentheses times, in parentheses, 9x plus 2. Now, when we're expanding polynomials, we commonly use a method called FOIL. Sorry for my atrocious handwriting here. Now what FOIL stands for is front, outside, inside, last. Basically, it is a method for expanding polynomials that involves multiplying all elements with each other. It's kind of similar to how we were taught to multiply two large numbers in intermediate school. For example, say you have 13 times 13. So there's a tens place and a ones place. It's really similar to this. So what we would do is we'll multiply 3, which is in the ones place, by 13. That would give us 39. And then we'll multiply 10 by 13, which would give us 130. And then with this chain here, we'll just add them together, and we get 169. It's fine and dandy, but now we are going to apply that concept to polynomials, and as you'll see in a moment, they're really not that hard. Most of all because they do not involve a lot of numbers. Let me clear my space up here. Find a better way to do this. Alright, so in applying FOIL to 3x plus 7 times 9x plus 2, firstly we apply FOIL by multiplying the front, and that's CF. So 3x multiplied by 9x, that gives us 27, which is 3 times 9, x squared, which is x by x. Then we multiply the outsides, which is 3x and 2. 3x times 2 gives us positive 6x. And then the next step would be to multiply the insides, which are these two numbers. We're looking at the when I say front, outside, inside, and last, we're talking strictly in a geometric sense. And it's how we're looking at it, how it's being written, and that's what we mean by front, outside, inside, and last. So now the insides would be these two numbers. Well, 9x and 7. 9x isn't really a number, so 7 times 9x would give us 63x. Finally, we would apply last. Last is 7 times 2, which gives us 14. So all we have to do is to add the two like numbers together, and we end up with 27x squared plus 69x plus 14. Alright, so that was simple enough. So this FOIL method works for almost any polynomial. However, things do get harder as equations become more complex, and that is where I shall start introducing a few more new rules, which will make things easier. So let's try this exact same form with this equation right here, or this polynomial right here. 54x plus 68 times 21x minus 17. So we would also apply FOIL here. And well, I threw in a bit of a twist in here because there is a minus instead of a plus, so that makes things slightly more complicated, but not by much. So front 54 times 21. That yields us 1,134 x squared. And then we multiply the outsides, and that gives us 54 times negative 17 is 918. Since it's negative, we have minus 918x. So now we multiply the insides. That's 68 by 21. That gives us plus 1,000 rather, and 428. Finally, last, which is in this case minus 1,156. So what we get from this is 1,134 x squared plus 510, that should say x, x minus 1,156. Big numbers, but not a big challenge. The key is to keep using FOIL, and that will see you through almost every polynomial until it gets more complex, in which case FOIL may actually hinder you. And we shall see that in this next form, which is in parentheses ax plus b times, well, squared. So with this form of the polynomial, we'll need to apply a special rule. However, let's just do this with FOIL first to show you the universality of FOIL. Sorry for that O. So with FOIL, first we multiply the fronts to get 25 x squared, and then outsides 30x. Now let me just rush through this really quick. 30x plus 36, 25, sorry, x plus 30, well, 60x plus 36. Alright, I'm gonna have to cut off my video here really quickly. Due to software limitations, I can only limit my recordings to about 10 minutes. Please look in the links or description or wherever I put this for the next part of the video, where I shall talk about the rule that we shall apply to this polynomial, and of course discuss various other forms.